Hi, everyone. My name is Jeffrey, and I'm a software engineer at Google. Today, I'll be talking about Graceful controller operations. Quick recap of the control plane. The Kube API server, we often think of it as the most important component on the control plane. But by itself, it acts more like a hub and doesn't really have any opinions about the state of a cluster. Those opinions are held by the Kube controller manager and Kube scheduler. Now, normally we want to be reliable, so we usually have multiple control planes.
Yeah.
Kube controller manager and Kube scheduler can often be thought of as the brain of a cluster. But what happens when you have multiple brains? Then you run into split brain scenarios. And if you have multiple instances of Kube controller manager, they could have differing opinions. And that leads to problems about the desired state not being in agreement. So to solve this, we use leader election. We have multiple instances of both the Kube scheduler and the Kube controller manager running. And one instance will be in active mode as a leader, while the rest are passive. And we implement this using a Kubernetes resource called the lease. This is basically a lock that the leader would hold. And all the other instances would see that a leader has selected and would keep watching this resource in case the leader becomes unhealthy. Now, how is this implemented in practice? This is a snapshot of what the Kube controller manager does. We have a library in client Go that does all this leader election stuff. And as a user, we just need to specify on-starter leading and on-stop leading. On-starter leading is what happens when a controller acquires a lease lock, and generally it will just run its control loop. On-stop leading is called when a leader loses its lease lock. And as you can see in the KCM instance, we call klog flush and exit, which just calls os.Exit afterwards. For this to happen, there's another component that it expects to restart the process once it exits. And it'll go back into passive mode. Some of the problems with this is that we skip cleanup operations because we just forcefully exit the pod. We have go routine leaks. And to solve the go routine leaks, we exit, so we clean up. But then it's unsafe to release a lock. We have a chicken and egg problem where when we shut down, we have no process to actually release a lock. And if we don't shut down, then it's unsafe to release a lock. As a result, when a leader goes away and the next follower needs to become the leader, then they'll need to wait a whole cycle for a lease to expire. This can be on the magnitude of big of minutes for larger clusters, which is undesirable. So what we've done in 135 is we've made the KCM graceful. We performed a cleanup operation and fixed all the go routine leaks, which makes it both safe to release the lock and also safe to not directly shut down. Yeah. And yeah, so this allows us for additional features like voluntary lock release through CLE and for certain components to not have to restart. So to summarize, KCM, we implemented graceful leader transitions for KCM, but it is often as a reference implementation for many of our other controllers built on KubeBuilder controller runtime. And so if you write your own controllers, see if you can adopt this kind of new pattern, and let's build better and more graceful controllers together. Thank you.